This is Python programming for artificial intelligence. In this session, we'll be looking at a library called NUMPY. And NUMPY is a very important library because it is used in creation of homogeneous n-dimensional arrays. Now, the advantage of using NUMPY as opposed to list or any other is because it consumes less memory space and it is also faster to execute. Let me also mention that NumPy was specifically created using C programming, and for those of you who have a background of structured programming in C, you will find the association very easy. So without wasting much time, let us proceed. We'll be moving on to our Jupyter notebook, and let us start by renaming the notebook. I'll rename it as NumPy and save it. So in this session, we're going to tackle the 13 tasks that I highlighted here as part of our learning process. And we'll start by importing the necessary libraries. So I'll be importing NumPy as NP. On execution, move on to line 2. And we'll now start our first activity. Let me just note it down here. And this will be create an array of 5 elements. So we're going to create an array of 5 elements. And this is how we're going to do it. We are going to have, let's say, array 1 is equals to np dot array. So np.array is the method that we use to create the array, and usually it is a list or a tuple inside a list. So I'll just have 5 elements randomly, random elements, 5 of them, and that marks our first array. So on execution, I'll be able to print our array, and you can see our result is coming out. Moving on to the next task, we are asked to get the maximum number of the array. So I'll just paste it here. So the maximum number of the array, we're going to use the max function. So we'll be applying the max function on array 1. So this will be np.max on arr1. And on execution, we find out that the maximum is 9. The next assignment or the next task, the minimum number of array, and I know you can already guess the method or the function that we use here, but let me just copy it and execute it. So we're going to use np.min. Remember, all Python commands are in small letters, so it has to be min, and I'm going to apply it on R1. So on execution, I find that my minimum is 2. The next activity is for us to get the min, and I'm sure most of you are now able to learn how this thing is going. We just apply the necessary method, and as a matter of fact, if you place a dot and press tab, you'll be able to see all the methods that are available. So for our case, we are looking for min, and we are applying min on arr1. So on execution, we find that the min is 5.6. Let's move on to the next activity where we are supposed to get the index number. We are supposed to get the index of maximum number of the array. So let me also paste this requirement. So for us to get the index of max number of the array, we are going to use argmax function. So this will be np.argmax, and we are going to apply it on AR1. So on execution, I see you're getting an error. There's a mistype. This needs to be a dot, and you can see we are getting it as 4. So we are talking of the index. Remember, we are talking of index of max number of an array. And let me show you something. This is our array, and usually our indexing starts with 0 when you're coming from left going to right. So if you're starting with 2, this will be index 0, this will be index 1, this will be index 2, and this is 3, and eventually 9 is index 4. Now, if you are reading from this end, then we usually start with -1. So in our case, we are getting the index as 4, which is correct, and therefore we'll be moving on to the next item. So the next is for us to get a sum. We're supposed to get the sum of all elements in the array. So let us see how we can accomplish this. So for us to get a sum, we're going to use the sum function. So it is np.sum, and we are just applying it on array 1. So let us see. It's giving us 28, and indeed if we try to confirm, 9 plus 7 is 16, 16 plus 10, 26, 26 plus 2 is 28. So we have it correct. The next activity is to get the sum of first 3 elements of the array. Remember, we are getting only the first 3 elements. So how do we accomplish this? Let me show you. For us to get the first 3 elements, we need to apply the indexing function, which I just mentioned. So we're going to say np.sum, and then this sum will be subjecting it to array1. But then for us to find the first 3 elements, then we need to use the indexing function. So I'm going to introduce indexing here, and in this case we need the first 3 rows. So we need to say it is starting from index 0 and it is ending on index 4. First 3 elements, we're going to type np.sum of r1, and then we need the first 3 elements. That means we need to use the indexing, and in our case we'll be taking up to index 3. So on execution, we find that our sum is 12. Moving on to the next activity, we are supposed to create another NUMPY array of same size as R1, and let me just show it, and add it to the array. So ideally we are creating another array. Let me just paste it here. We are creating another array, and we're going to add it. So let me just paste. Let me just delete this one and make it as a markdown again. So how do we do this? We are going to use a function, and this time I'm going to say r1 is equals to np.random. We're going to generate it using random number, and we're going to say rand int. In this case, we're going to have 1, 11, and we also need to specify the size. So the size for this, we are going to say 5, 2. So ideally, this is 5 rows and 2 columns. And if I enter, sorry, I'm getting an error. I just need to see. And this is actually the beauty of this. So for us to do this, we also need to introduce the 2 commas and then execute. Now we have created another array with the same size, and actually this is going to be an array of, this is the starting number and this is the maximum, and maximum is not included. So we'll have an array of between 1 and 10, and we'll have 3 rows and 4 columns. Let us see. There are 2. If I run it, you can see we have 3 rows and 4 columns, and therefore we've been able to. If I run this again, I just want to show you guys something. If I run this again, you can see my numbers are changing. You can see these numbers are changing. Immediately I rerun, these numbers are changing. So there's a function which I want to show you, which is also very helpful when it comes to controlling this. I'm going to introduce np.random.seed, and I'm going to use any number here as the seed. Let me use 5. And on execution, now you realize that my numbers will not be changing. So this np.random.seed function helps us to ensure that we have consistent results across. Otherwise, our result will be changing again and again. Moving on, get the max value in the 2D array. So we also require to get the max value for this array, which we have just created. So let us see. We're going to use the max function, but considering this is a 2-dimensional array, we need to apply more arguments. So we're going to say R2, and then we need to introduce axis, which is 1. So if I say axis is equals to 1, basically this is directing this program to work with 7 is the maximum for the first row, 10 is the maximum for the second row, and 8 is the maximum for the third row. What happens if we say axis is equals to 0? If we say axis is equal to 0, then we're going to get 10, 9, and then 8, 8. So when we say axis is equals to 0, then this function will be looking at the columns. You can see we have 4 values because of the 4 columns. So it is going to look at column 1, what is the maximum, column 2, what is the maximum, column 3, what is the maximum, and also column 4, what is the maximum. So when we say axis 1, it means it's looking at the row wise, and when we say axis 0, it is looking at the column wise. Moving on, we need to create a data frame from a dictionary, e.g. student with scores and grades. So let me also copy this. So we are required to create a dictionary. So let me just execute this. So we are asked to create a dictionary for student. So I'll just type student. Let me say student data is equal to. Now remember data types, and specifically when we talked of dictionary, this is how the dictionary is created. I'm going to have name, name, and then we can have the names of our students. For instance, we can say the first student is Alice. We also have another student called Jacob. And let's say lastly, we have another student called Steve. So these are our 3 students. We are now going to have the scores. Our score is, I'm just going to take random numbers. Let's say we're going to have 85, 34 or 45, and another one 56. So those are our scores. And lastly, we are now going to have our grades. So our grades, we have 85 will ideally be an A. So that is an A. 45 will be a D. And lastly, 56 will be a C. So those are our grades. And by doing this, we have created our dictionary. Sorry, I forgot to put the closing parenthesis. And now we are able to have it here. So we need to convert this dictionary to a data frame, and I'm going to say df is equals to pd dot data frame. Let me see if I press. Now this is not coming. Data frame is not coming because we need to import pandas library. So I'll be importing pandas as pd. And I can see we are having an error here. Let me just execute this on its own. Thereafter, I'll say df is equals to pd dot data frame. You can see now the data frame is coming since I've been able to execute the pandas. And I need to pass this to student data. So I'll be passing this to student data. And therefore, I have my data frame ready. So let me see if I press DS. We now have our data frame created and available. You can see the name, scores, and grades are a true reflection of the dictionary that we created earlier. So moving on, we are supposed to display students who have scored more than 80. Students who have scored more than 80. And again, as usual, I'll be copying it here. So for us to display students who have scored more than 80, we're going to run df or so for us to display students who have scored more than 80, we're going to do something called cross-referencing. But before then, let me just show you. If I do df of scores, df of scores, and we are saying we want more than 80 marks. So if I enter, you realize that we only have one true, which is Alice, who has 85. Jacob and Steve are turning false because they do not meet 85. Now, for us to get the desired result, let's do cross-referencing, and I'll just insert a df and brackets and execute, and you can now see that I'm able to get the desired result. Moving on, the next item is to display students who have scored grade A. So let me just paste here as usual. Students who have scored A, just the same as the way we did for students who have scored more than 80. We are now going to use the grades column. So I'm going to say grades, and then we are saying grade is equal to 80. If I run, realize that all of them are turning false. Hold on a minute. I meant it should be, instead of 80, it should be A. And we have one student who has an A, and that is Alice. So again, cross-referencing will give us the exact output. Let me just do cross-referencing, and therefore you can already see that we are getting the desired result. Now the last activity is for us to generate zeros and ones, and we're going to use a method in Python that is available. It's called NP dot ones, and this is used to generate ones. If I do this, I need to give it an argument. Let's say we need 5 of them, so it gives me 5 ones. The same thing can also happen for zeros. We can say np dot zeros, and we have our column. We can say we need 8 of them, and I need to have a dot here, and you can see we have 8 zeros. So this takes us to the end of our NumPy tasks. Next coming up is pandas. I'd like to thank you so much for finding time. Thank you for viewing. I hope this has been informative. Thank you.